times the design current times the length divided by 1,000. That will give us our volt drop.
Yeah,
for the installation.
Absolutely. So if we just have a quick look, we can see that we get the millivolt value from, as you say, table 4D5. If we read for 2.5 mil twin and earth cable, we can see that that's got a volt drop of 18 millivolts per amp per meter. And then looking at the calculation, we need to do the volt drop from the table, which was 18, multiplied by the current, which the question told us was 20 amps, and the cable length was 40 meters. So 18 times 20 times 40 gave us 14,400. And then always remember that the volt drop is in millivolts. So then to convert that to volts, we need to times it by 1,000. We also did, just for completeness sake, I know the question didn't ask it, but what was the percentage? So if we looked at the volt drop divided by the 230 volt supply, that would have given us a 6.26% volt drop. So a bit higher than we would like. We were talking earlier about, you mentioned some other points about volt drop that people often fail to consider. What kind of things would we always recommend people look at, James?
I mean, I would look at that's the volt drop of the final circuit, but there's a lot more to it than that in terms of the circuit supplying the final circuit. So you could be in a typical house, you might have the switch fuse at the start of the property, and then you might have the fuse board, say 30 meters down the line, and then you would want to look at sort of adding the volt drops together, which you can do. I mean, you can. What you're best off doing is converting it into a percentage each section, adding a percentage up, and not exceeding 5%.
Yeah.
So you do your calculation for the first, but bearing in mind the current demand of the submain is likely to be a lot higher than the final circuit. So it's important to do them separately, and then you may have 3% on one, 1% on the other. Add them up, and then you don't want it to exceed 5% overall.
Yeah. And that's often the case, isn't it, on those larger jobs where you've got subboards feeding subboards, then quite often we might need to oversize the distribution circuits just because of volt drop, not so much because of current carrying capacity, but purely so that we don't run into volt drop problems, because on jobs, volt drop can often be the first thing we come across, even though we've sized the cables correctly for current carrying capacity.
Yeah, I mean, again, if it was 400 volts, you would have to do that as well. But in that case, you'd use the line voltage drop as your factor. So you'd actually, and then you want to add them up separately because it's very different. The percentage is a big gap between 5% of 400 volts and 5% of 230 volts.
Yeah.
And then you want to sort of add them together, cascade them as such.
Absolutely. Okay, while people are putting in their questions, we'll have a look at some that we've held over from previous sessions. So first one tonight is, can an electrical installation be inspected and tested for compliance with BS 7671 by a company who were not involved in the erection and or construction of the installation? So this question often comes about when people are employed to do the installation aspects, and then they find that on site there's going to be a separate company doing the test and inspection. So what does 7671 tell us about it? Well, yes, it can be done by a separate organisation, as long as the required inspection and testing takes place during the erection phase of the installation. And that's the thing that people often miss out, is 7671 is quite specific. You can't just wait till the end and then do your inspection and test, and that's because quite often cables will be hidden in the fabric of the building at that stage, and so you won't be able to fully inspect them, for example. So the regulations that talk about the required inspection and test are quite clear, and if we just have a look at 134.2.1 about fundamental principles, says that during erection inspection and testing has to take place, and that's that's also echoed in the Reg 641.1, where it says every installation shall during erection be inspected and tested. So yes, it's possible that a separate company can be employed to do the inspection and test, but it has to take place, the appropriate testing has to take place during that construction phase. So it's not just a case of them turning up at the end and doing the required inspection and testing. There should be a degree of that performed during the installation phase of the project.
I'd say with that as well, getting it very clear contractually who's responsible for what as well in the early stages, and good line of communication between the two, and making sure the signature's right on the paperwork to match who's done what aspect of the installation prior to it being sent out.
Yeah, really true and really important, and that's why you know the standard template for installation certificate, which shows in 7671, it actually has the option of those 3 separate sections, doesn't it, for the designer to sign as a declaration of what their intent, and then separately the constructor or installer, and then again separately the inspector and test. So the certificate caters for it, which gives you a heads up that it's certainly something that's permissible and compliant with 7671. Okay, another one that hung over from before is an old favourite. Can I fit a socket outlet? Can I fix it internally to kitchen units? So what's our thoughts on that, James? Can we fit accessories such as socket outlets to kitchen units?
I mean, in my domestic experience, I think sometimes it's almost impossible not to, a lot of the time. So, I mean, what I used to always make sure is that I fitted it to the most solid part of the cupboard you can with a unit, whether that's the side pillar, generally not the back panel, because that's really flimsy and can be pulled out quite easily and damaged. But really, you want to put it on a very rigid, most rigid part of the unit you can, and also avoid sort of any places where there's water. Try not to keep it too close to them at least, so it's well out of the way of likely if anything happens with regards to if it's under a sink, say. You don't want to try not to go there, but if you have to, just make sure you're keeping your distance. And same, you might have like water heaters under the sink or sort of kettle boiled taps and everything. Just you want to make sure the wiring system's protected from any adverse effects from heat, water and the usual requirements really, but it's acceptable.
Yeah, and you spot on in that just because it's in a cupboard, you still got to think about the environment that the equipment's being installed in, isn't it? So yeah, is it going to suffer adverse heat, adverse humidity, or even water ingress? So yeah, really important. One thing also to mention is that this is one of those questions that's covered in Electrical Safety First and the RAG, the Wiring Regulations Advisory Group questions. So for those that aren't familiar, those are freely available on the Electrical Safety First website, and there's a whole host of frequently asked questions and answers from the electrical industry. They really are seen as being industry standard responses, because it's not just an NIC view. You can see from the slide there that we've got on screen all of the different organisations that contribute to the RAG committee, means that it really is seen as industry guidance. So you've got ourselves, you've got other competent person scheme providers and other trade memberships, so NAPIT, ECA, Select. You then got the manufacturers represented by BEMA, the likes of the IET, City and Guilds, LCL Awards. So yeah, all key stakeholders in the industry, which is why we really do feel happy in saying, that really is recognised as industry guidance, and freely available on the website for anybody to see.
On assessments, I'm often, if I get a question like that, if I know it's in the RAG, I'll bring it to their attention, because it's quite often a clear-cut answer, which is rare, isn't it? I think so. It's really good to have that source where you can find your answer that quickly. It's also, you want to make sure, talk to the customer as well, what they're intending to put in the units, because whatever's being stored in there, you just need to know, I think, just to stop it getting obstructed, so you can't access the point and prevent access in the future.
Yeah, no, really true. You know, so if, for example, that's your point of isolation, then that should be readily available. So shouldn't get covered by food tins. And likewise, if there is a functional switch in there, the last thing you want is somebody putting in something into that cupboard, inadvertently operating that switch. So yeah, a good point that you should really think about what it's being used for. Okay. We'll take another question from the previous pile. So, when wiring smoke detectors into domestic premises, is it a requirement to use red 3-core and earth, or will the standard grey 3-core and earth be acceptable? What's your I think this one was my lead, wasn't it? So we took a look at this one from 5839 Part 6 standpoint. So 5839 being the British standard for fire alarm and detection, and Part 6 being the domestic section of that standard. And that's quite clear in that the outer sheath does not have to be red in colour. There's no requirement. Within 5839 it specifically talks about cables for the mains supply and smoke alarms and any heat alarms. Interconnecting wiring should be suitable for the domestic mains wiring, so twin and earth would satisfy that. Conductors used for interconnection of smoke heating alarms should be readily distinguishable, so that can be done with sleeving of the cores, and then wiring systems of any circuit in a grade D system should conform to the general requirements of 7671. So there's no requirement to use, we know that there is a version available, but there's no requirement to use a twin and earth with a red sheath. There's nothing to prevent you using standard grey sheath twin and earth.
Yeah, I think from experience, quite often gets metal confused with that is putting brown sleeving on the interconnecting cable, isn't it? 5839 alludes to not doing that because it can be confused, and so I mean, I think there's not really a set colour to use, is there really? No. As long as it's quite easily identifiable and separate to the rest.
Yeah, and that, I think that's what 5839 is trying to say, is that they want it to be distinguishable from that already, so that it's not then going to cause confusion. Let's have a look at another one. So what IP rating is required for outdoor lighting? What's our thoughts there, James?
I mean, section 714, it would be, they would say IP33, though section 714 actually excludes lighting to the dwelling connected to the internal wiring, but I think it's a very good rule to apply, would be IP33 or 33. It's a good standard to work to, though I'll say the fixed lighting on the building is excluded from that section. Yeah.
So outdoor lighting specifically says, if you're fixing the light to the outside of the building, then that's not really considered outdoor lighting, because the cable would only pass through the exterior wall to get to the light fitting. So this is more than lights away from that, so garden lights, standpoint lights, and it seems a little bit low to a lot of people. A lot of people always expect it to be 44. It is in 7671 as 33. One thing I always say is that 7671 is a minimum standard. You can always go over and above. What you can never do is go below. So if you as the designer, installer are more comfortable with 44, there's nothing to prevent you doing that. It's just it's clear that in order to meet minimum requirements of 7671, it does only need to be IP33, although I'd always refer people back to the fundamentals section at the start of the book, which says everything needs to be installed which is suitable for the environment in which it's being installed in, or the way you install it makes it suitable, because one of the other things that that is brought out in section 714 is that your equipment should be capable of coping with that very wide ambient temperature range, you know, minus 40 to plus 40, although I can't remember when we've ever had anything down to minus 40, but and then also you know, quite high humidity, so think about that as well when you're selecting your manufacturer's devices.
I mean, from experience, I think most outdoor lights I ever installed were normally at least a minimum IP33, normally exceeding that, to be honest, from experience. I think most outdoor stuff rated and declared suitable for outdoor. It's always worth checking, obviously.
Yeah. Okay. So please do. I think we looking at the chat, there were some sound issues, but hopefully now that's in. So it says that the sound issues have been resolved. So apologies for those people that suffered some sound issues at the beginning. Hopefully you can hear us now. I'm just looking through the chat to pick out some of the questions. So the first one that's there is, if an EIC is used to both certify a new circuit but also minor works to several circuits to avoid using multiple certs, this would mean different retesting periods. How do we record that on the cert? So I think what the engineer there is asking is that if they're doing both a new circuit and additions and alterations to existing circuits, but they're certifying them all by using an installation certificate, how would they record the recommended date for the next inspection? Because obviously some of the older parts of the installation which weren't modified or altered would be in an older state. It's quite clear in that the certificate will only cover the work you've done, and therefore the recommendation for the next inspection is only applicable to the work you're done. So if I try and give the example, if you've modified circuits 1 and 2 but you haven't modified circuits 3 to 8, and then you've added circuit 9, you would put a date for the next inspection based on circuits 1, 2 and 9, because that's all your certificate would cover. And so the date for the next inspection on circuits 3 to 8 should still be done based on the original installation certificate which covered those that work that was undertaken. So did that make sense? It's one of those ones, I know what I want to say, James, but I'm not sure I said it in the right way.
I mean, I think what will you get? I mean, any addition, the existing arrangement's got to be adequate, obviously, for your addition. So it would only be your addition that you're declaring your next inspection date on your particular part of your addition. And I mean, the certificates, there's so much room for comments and description now. Just be very clear as to what you've installed and what your next inspection date actually specifically relates to, I would say.
Yeah,
enormous boxes now.
Yeah,
on the second page.
Yeah, and it's, you know, I think sometimes people get concerned that if they've only worked on part of the installation, their date that they're recording for the next inspection covers the whole of the installation, and it doesn't. You know, it only covers the work which is covered by that certificate. So, you know, the date for the next inspection only refers to the circuits that you've talked about as being added or altered. So again, it's another one to be nice and clear, just what you have done, what you're taking responsibility for, and then that then becomes clear. It's those things that are being used for your date for your next inspection.
And obviously on assessment, always talking to my contractors about being as clear as possible in the extent. You get quite generic comments like 2 new circuits, but just be as specific as possible as to what you've added, what you've extended, and that way you're protecting yourself, really.
Yeah. Okay, another one which is it's quite a common question, especially on large installations. So I'll try and do it justice. I have an MCCB in a panel board supplying a sub-distribution circuit some 100 metres away from the incomer. and it doesn't comply with the maximum ZS, and the engineers put in brackets it's not far out. So the ZS at the panel board itself is already a bit high before you even take into account the sub-circuit, so it's going to be very hard to get the reading down low enough with cross bonding to steel, etc. I looked at an adjustable RCD with settings up to 3 amp installed at the start of the sub-circuit, but it's far too risky with it being a call centre and servers involved, etc. What would you advise? So yeah, totally understand why, although an RCD would have the maximum ZS probably that can you achieve, you wouldn't want to put a single point of failure at the front end of a large installation like that. So yeah, I think as one of the other engineers has referred to later on in the chat, have a look at 419.3, which talks about when you can't achieve the maximum ZS for your protective device because, like in your instance, your effectively your ZE or your ZDB to the first board is higher than the maximum ZS for your protective devices already. What you need to consider in those situations is at that intake position you've got to consider bonding everything so that although you know you won't achieve the required disconnection of 5 seconds, for example, or maybe it's 1 second for a TT, eventually your protective device will operate because it's if that fault current is large enough, it just won't operate in time to achieve your maximum disconnections for protection against electric shock. So what you need to do is bond the extraneous conductive parts and exposed conductive parts in that area together so that for the time it takes your protective device to operate, during that time you won't get touch voltages between simultaneously accessible parts greater than 50 volts. That's what you're trying to achieve. So it is quite common, especially in large installations where you've got very high currents coming in, but you've got a very low, because of that your protective devices are expecting a very low ZE, but you might be some distance from the supply, which means that even the ZE might be greater than the maximum ZS for your protective device. You can still go ahead and as the engineer has said, have a look at section 419, which talks about being able to bond everything in that area, and then hopefully when you get to the next sub board or distribution board, now your currents are lower and then the protective devices will be able to achieve their maximum ZSs. So yeah, it's doable and it is a common occurrence.
Typically how you'd look at that sort of formula, you'd be 50 volts divided by the instantaneous operation of the device, and whatever resistance that is, as long as you're within that, your touch voltage should not exceed 50 volts until it ultimately disconnects. That's the theory behind it.
Yeah.
So it's the same as supplementary bonding in a bathroom, isn't it?
Yeah.
50 volts divided by the 5 times of 30 on the 6 amp breaker, for instance.
Yeah.
And then and keep your max ZS, keep your ZS within that.
Yeah, and I think sometimes people get a little bit confused in that they think, oh, I'm greater than the maximum permitted ZS, therefore their protective device isn't going to operate. It will operate, it just won't operate in the required time to achieve your required disconnection. So that's what you've got to think about. Okay, for the time it takes the protective device to operate, can I make sure that simultaneously accessible parts are not going to rise to a different potential, which is going to involve electric shock? So normally we're talking about all of the metalwork, the trunking, the distribution boards, etc. in the intake room, and we bond that all together so that we're not going to see any potential differences. Okay. So someone, let's just see, it might not be the measured prospective short circuit current of 4.6 kA on a 3-phase distribution board. So after doubling to 9.2 kA, the board had single phase 6 kA MCBs installed. Do they need to be upgraded to 10 kA? Well, the doubling is a rough rule of thumb. It's not quite doubling actually if you do the maths fully. But doubling 4.6, yeah, even if we do it by 1.7, you're probably still going to be greater than 6 kA. So yeah, we would certainly recommend upgrading to 10 kA, just so that you've got devices that will withstand that prospective fault current and still be able to operate again if there is a further current after they've been reset.
I think typically the ×2 value is related to all lines touching at the same time, isn't it, rather than sort of single fault conditions.
But worst case scenario, that's not likely to arise. So, but yeah, I think even if it were lower, the fact that you're already measuring 4.6 kA on one phase, we would certainly recommend going to 10 kA rather than leaving those at 6 kA. One more from the field. So I've attended a property where the incoming supply is overhead. It's you've put TICS, but I'm assuming that's TNCS. The DNO have confirmed this. Measured ZE is 0.46. Yeah, I think it should have been TNS because you've said it's higher than the 0.35. I've contacted the DNO and they said because it's remote, so they can't get it lower. Would we just make a note on the certificate, full RCBO board and SPD installed? Okay, so again, quite a common question we get. The 0.35 figures for TNCS and 0.8 for TNS, they're quoted as typical values that we can use when the supply isn't there yet, so we can use them when we're doing our design calculations. But ultimately the DNO don't have to achieve those values, so perhaps, as in this instance, they've got a TNCS where the ZE is 0.46. It's higher than the 0.35, but they're not going to do anything about it. So long as it doesn't cause you a problem, so it doesn't increase that much so that none of your overcurrent protective devices work, and the fact that you've said you've got a full RCBO board will mean that they will definitely be okay, because the maximum ZS for the RCD side of the RCBOs will be much higher than 0.46. We would recommend recording it, because one thing you do want to know is if that continually gets higher. So if at the first 5-year check it's noticed that it's now doubled from 0.46, then that's information that you should go back to the DNO with, because it could be an indication that you've got a problem, insulation perhaps breaking down in the distribution network. So yeah, definitely record it. Definitely, I would suggest record the fact that you did contact the DNO and they said because it was remote they wouldn't get it any lower, and then you've done everything reasonably practical. So yeah, record those things, and you definitely want to record the value, because at a later date, whenever you're perhaps doing some further additions and alterations there, or you're just doing a condition report, you'd want to check to see that it was a stable value greater than 0.35 and not something that was incrementally increasing from 0.35.
Probably what I'd add to that is the tester as well. I'm sure it is, but triple check that the tester is, the leads are all okay before sort of contact DNO, because quite often on assessment we end up bringing it down to it's actually a lead that's caused a slightly higher resistance. I mean, 0.46 is a relatively high number for a PME TNCS system, isn't it? So quite often on assessment we drag it down to, and it's actually the leads that are causing sort of quite a bit of resistance.
Yeah, no, that's a good shout. Double check, isn't it? It's always measure twice, cut once. Okay, so at the moment that we've got another one. Can you change the certification software so that when we fill out a green EICR, we can then copy it into an NIC EIC installation certificate without having to retype all again? And the engineers said not really technical. So I know that's a common question, and people have often wanted to do it, in particular like this, where they've gone from doing a condition report and the next thing they're going to do is an installation certificate, and likewise going the other direction, where people have have gone from doing an installation certificate and then find they want to do a condition report. It is being worked on. You can certainly copy values, but I would need to, what we'll do is we'll try and get your details, and I'll get hold of somebody on the certification team to be able to give you an update on that.
I've used that software a lot. When you're creating your certificates on the finalised ones, the little dot on the left, click on that and it will open up 3 options and you can convert to an EIC. I'm assuming by the question that this contractor is a domestic installer, because if he's using the green forms.
Yeah.
If you're approved contractor, you can 100% go red to red. So you can do a red EICR, approved EICR, and convert it to an EIC and back and forth. But if it's a non sort of affiliate one as such, then I'm not sure if that allows you to do that. I'd have to have a look.
Yeah, to
go from green to an approved one.
Yeah.
A domestic one.
No, I think you're right, and that's what I'd take from the question as well. The fact that they've got a green EICR would tell me that they're currently registered as a domestic installer, and so therefore only have access to green EICRs. Because as you say, if it were, if you perhaps registered for the private rented sector scheme, or you were an approved contractor who'd been assessed for condition reporting, then yes, you'd have access to both, and then you can switch from one format to the other. Let's have a look at another one in the chat. So, are the manufacturer's blanks supplied with DBs normally in strips of 5 single way and made of plastic compliant to 7671 that fit in the lids, as these can be removed without the use of a tool? Again, a common question that we get asked, because that there is a requirement in the section for barriers and enclosures to make sure that anything that's specifically there to prevent access to live parts needs a tool to remove. Currently, I think there's again a question in RAG on that. So
there is. Yeah, definitely.
I was just going to pull up the answer on that to advise people. What we'll do is we'll have a look at the next one, and then we'll circle back onto that one.
On the Q&A, once you get up, it does say it is suitable as long as it's made by the same board manufactured blank. It is almost fine as long as it's secured in place.
Yeah.
And it comes with a board and it's fit for purpose.
Yeah, I think that's the idea, that it is, it meets that manufacturer's equipment requirement, so it's something that they've designed for that purpose. What we want to try and prevent is people, cutting their own plastic trunking lids to make inserts for boards, and then therefore they're not fit for purpose. So yeah,
it's 1.45 on the insulation part of the rag.
Can you just read us what it says?
Yeah,
James,
sure.
So
it says question 1.5: do clipping blanks fitted in a DB or consumer unit comply with the requirements of 7671 with regards to access to live parts? And the answer is yes, provided that distribution board or consumer unit conforms as BS 60/61439 is fitted with blanks that are firmly secured in place with sufficient stability and durability to maintain the required degrees of protection and appropriate separation from live parts under normal service conditions. Distribution board or consumer unit manufacturers can supply blanks to meet these requirements, and it does have a note about blanks not being interchangeable automatically, and really should be it's the rule with anything manufacturer wise. Distribution boards try and keep to the same makes of everything.
Yeah, 100%. Another one, following from the ZE question, we've got 2 mega multifunction testers with a difference of 0.13 ohms on earth loop testing. This can sometimes mean the difference between a satisfactory or unsatisfactory result. Advice, please. I think the advice there is you've got to if you're measuring them on a known installation and you're getting a variation, then there's something not right, and so perhaps you need to look at getting them calibrated by the manufacturer, or can you look back at your own recorded tests to see if on a known supply things have varied in one from the other. But yeah, you shouldn't be seeing a variance like that, so perhaps one or both multifunction testers need to be looked at to see if their calibration is correct. Would you add anything to that, James?
Again, that's sort of what I was alluding to about the ongoing accuracy, just using a known source and regularly checking throughout the year. I mean, I'm assuming that you're interchanging the leads and it's still doing it. So in that case, it looks like there may be an issue with the tester, doesn't it, I'd say?
Yeah.
In some form.
Okay. Yeah, I apologise. Someone said, could we keep the slides in sync with the conversation? And because I'd left the previous question up. So yeah, fair comment, and I've caught up now. I've located an interconnected circuit more than once on an EICR. What's the chance of a column verifying no interconnection between circuits on future schedules using an AVI as a test method? So it's something that we can certainly feed back. You know, quite often we get it, and particularly with shared neutrals on in installations, particularly domestic, but also we get it a lot in larger installations too, where people have taken a bit of a shortcut. So yeah, it's something that does need to be verified, especially if you've got isolation issues. Yeah, we can certainly take that on board and feed that back to see if it's something that the industry would like to include. We'll take a few more. TT overhead supply with earth rod, what type SPD is required? Well, generally, unless it's an installation that's got lightning protection, then we'd still suggest a type 2 at the origin of the installation, and then if there were further equipment, typically more than 10 meters away, that also required protection against transient overvoltage, you might need further type 2s at distribution boards or type 3s at more vulnerable equipment.
Well, with the SPDs, you do. I mean, I think generally most are CT2 now, aren't they? Configuration type 2. There was a period where you had configuration type 1, which I believe is the one that's not suitable on TT.
TTs, yeah.
Double checking, yeah. Because of the makeup of the unit, it creates almost a direct connection to live earth, doesn't it?
Yeah.
So with the second, with CT2, it has a chamber in between, so it prevents that, because your overcurrent device wouldn't blow, would it? So, but I think generally the manufacturers are quite clear on their instructions, what ones are suitable for TN and TT systems. They're generally very clear on it.
Okay. We've got one more that we've had hanging over, so let's just shoot across to that one. So what classification code is recommended for on an EICR for the absence of AFDDs, arc fault detection devices, in higher risk residential buildings? So what's our thoughts there, James? Well,
we talked about this before we started the live chat. And I mean, the best practice guide 4 would typically say code 3. But I think it's really important that you check is with current legislation. Regulation 421.1.7 states the requirements for AFDDs where they're required. However, it does have a note about sort of the what type of building constitutes a high risk residential building. It quotes 18 meters in height and 6 stories, but the current legislation, I believe, actually differs slightly from that, as in I think it might be 7 stories. So it's worth checking the latest legislation always, and whoever's in charge of the property and whether that is actually a high risk residential building.
Yeah, because we were talking about the Amendment 2, which introduced that requirement for AFDDs, was published before the more recent legislation that came out covering higher risk buildings in England. So that's perhaps why there's a little bit of a discrepancy between those two. But I just thought it was worth pointing out, this is one of those instances on an EICR which highlights the fact that although it's non-compliant, it's not necessarily seen as unsafe, and that's made clear in the front of 7671, where it talks about existing installations that had been designed and installed in accordance with an earlier version does not necessarily mean that they're unsafe because the requirements in the later version or current version are enhanced. So it's very clear sometimes that just because it's non-compliant doesn't make it unsafe, and that's that's referenced at the start of 7671. And James referred to Best Practice Guide 4. Again, Best Practice Guide 4, published by Electrical Safety First in conjunction with all of those stakeholders in the industry that we talked about, and that also recommends that lack of AFDDs is recommended as a C3 classification code.
I'm not sure the question said socket outlets. Does it say socket outlets?
It didn't on the question, but that's because that's the only requirement in 7671. It's for socket outlet circuits rated up to 32 amp.
Outside of that, generally, wouldn't be classified with a code at all.
Yeah, absolutely. So if it was, for example, a lighting circuit, then it's not seen as as non-compliant at all. Okay. Once again, I was talking to James at the start saying this will be the quickest 45 minutes of his week, and we're just about there again already. Just a few things I want to make you aware of. So we're currently madly working on the next series of wire, and that will start on Wednesday the 1st of May. We're putting the final touches together for what those are, but we know it's going to include a session on safe isolation, a session on EICR coding, overview of the building regs, and then the requirements for mandatory technical competencies. And also to let you know, please do keep in touch as we've done this on our social media channels, Facebook, LinkedIn, YouTube. We do also post out our question of the week every week on those channels, with the answer coming out at the end of the week. So please do keep in touch. And lastly, just to say thank you very much for contributing tonight. Once again, we've had some good questions, and it's been great that people have been helping each other and answering the questions in the chat, which is really good to see, because that's part of the whole purpose of this evening. So please do join us again. Now next month, again, it's not the Monday, because Monday just happens to be the bank holiday. I should have mentioned at the start actually that we did think about doing this yesterday on April 1st, but we just were a bit worried about the sort of questions we might get on April Fool's Day. So yeah, we decided very quickly to swerve that one and go for Tuesday the 2nd. Because but that we might do it one year, so perhaps think about a question that you might like to ask us on April Fool's Day. That might be a good session one time. So other than that, from myself, thanks very much. From James,
thank you.
Yeah, it's been really good.
Yes.
Hopefully you've got it out of it. Thanks to everybody that contributed with the questions in the chat. And we'll hopefully see you again in the very near future.